Hello there, ladies and gentlemen. I know the enforcement, and today, the viewer on the screen is gonna watch a video about my website. Oh, yes, that's crazy. A website that I made. It's insanity, you might be thinking. Well, to that I say it's not nonsense. Come and take a look. It's really cool.
Why, hello there again, and it appears now we are on the website. And because of that, I am going to show you it. So first off, the first section of this video is going to be dedicated to the website itself. So, you can learn about me, Nerdy Enforcement, the creator of this crazy website. So, small beginning, grand entrance, hi, Nerdy Enforcement, blah blah blah, loving creator, I'm an amazing person, I know, thank you. It's the copyright day, all the funny stuff. Next, you can see some products I made. A bird feeder that vibrates and squirrels get on it. I did this for a science fair, and it's really cool. And a card game that is amazing, immaculate even. It's social deduction, but with all these are unique roles with 5 different factions. On to the next point, we have the contacts page, where you can, if you have any questions, you can of course email me, get my Discord, or you can go to YouTube. Now, this isn't the main stage of the show I'm presenting here. No, the main stage here is the coding. Yep. So, the main website, they all follow the same formatting. I'm not going to go over each individual one because they're near identical. But I'm going to go over index.html because it's the most important website. You might be going, whoa, 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 whoa. What's index.html? And into that response, I tell you it's the homepage. There's not much to the homepage. There's not much to the homepage, but that doesn't mean that there's not much to the homepage, but there's a lot to explore through that small stuff. Mainly a game, a physics engine, a game, some might say, and others might say Among Us. But before we can get into the game, I need to explain how the HTML works. So first off, you have the header information, meta, like your UTF-8 character sets, the viewport, your description, author, links that came with like the bootstrap, funny little icon. And then importing the style sheet. Great. Now we're on to the body. The header here is pretty simple. It uses some CSS. You might be going, why don't you talk about the CSS? Well, unless you want me to discuss for an hour, over 10,000 lines of code, nah, I don't think so. But you notice how each one of these is a different end? Well, that's because the website here has layers. There's a background image and several layers, but each of these things can stack. That's how it originally came. And if we look at the products page, like these things are stacking. But in order to create this really cool effect, you get this, a lot of CSS. I'm not going to talk about the CSS in the show. However, I am here to talk about the HTML. So you have your navigation, a link that tells you. Now you might be thinking, what's next on our list? What's the HTML look like? And I'll tell you what this HTML looks like. Well, for our index HTML, we have, I know it's crazy, a header. Insane, I know, but the header contains, on all the websites, this area up here, from these 4 buttons that take you to the different HTML pages, and the funny words at the top here. Now, you might be asking yourself, after we go through the header and the navigation to the different buttons, we have a container, which contains a canvas and images to import to the JavaScript, because JavaScript is giving me a headache. But basically, all the images that you'll see in a minute here on the display of the homepage are brought in through the index.html because JavaScript was giving me a hard time. Then once it loads in all the photos, it loads in the JavaScript game. The JavaScript game file. And the rest is history. Then from there, we get into the final section, the bottom row, which just kind of looks like this. I know, shocker. They're different, a little different on each one, but once again, nothing to write home about. It's just a little blurb of funny info. Now, we can finally get into my favorite part, the absolute best parts of society, JavaScript.
Now back to the computer side. Back to the canvas. We have, of course, the little soldier character. Now, the way this game works is you hit the S is the home menu. You're gonna hit S to choose your class, which is gonna be soldier, because it's the only one available. And right now you can see I'm moving a little bit, and I am jumping successfully, and it is doing a. It is a physics engine, and it is adjustable. The values are adjustable, as you'll see in a little bit. But the key thing here is, using JavaScript, I was able to make this little character, this little goober boy, jump around and hold a rocket launcher. Now, the rocket launcher didn't get enough time to finish that. But this was already hard enough as is. During the first part up here, you can change the JSON soldier file to adjust like the speed, the height, the how high you jump. Because right now you can see it's not that high. It's not great, and you don't even stay in the air that long. But compared to last time, I increased the value of your weight, and you stay in the air longer, but it's the same height. This time, I adjust the jump height, and now Now I increase the speed, and look, I'm a little floatier. It's pretty cool. Now, I all did this with just typing in like 4 numbers. But, in order to be able to make it this compatible, there's a lot of work. First off, we translate the JSON files over, and we have some constructed classes that are used when you choose the class at the very beginning of the game when you press S. However, that is just not available because there's only one class available, so it just automatically assigns you to who? Soldier. Other key things to note, you'll notice underneath there's some custom values. Those just keep track of information like your positioning and other fun little things. And the way you're like angling your rocket launcher. Then there's some weapons. The actual rocket launcher itself has its own own object, and also the projectiles. And you'll see what we're looking at now is the constant variables, the more important stuff. So gravity, your ground coordinates here. The way the character knows that like to stop on the ground is it's just a coordinate, and if it goes above that point, because JavaScript goes from top to bottom, it'll stop moving. Yeah, so top is 0, by the way. Bottom is whatever you want to make it. In this case, it's 690. And then I just upped it so it looks like you're above the ground. And then you have gravity, which I mentioned is blocks. It moves in blocks. So to 30.272 is one block in this game of pixels. Which is what a lot of the movement, like the jump, one jump is 4 blocks. 3 blocks. So, but that just little self things. And then finally, gravity's always pushing at a certain rate, and I can adjust it to how I like it. But it's global, keep in mind, so I'd have to readjust all the other characters too. And then you have the init. When you set up, it grabs the images when the website's loaded, and then it runs the infinite loop, which is a recursive loop. However, it won't be taking your computer because it runs at a frame rate of whatever the Windows allows it to be. So, in this case, my computer would run at 144 frames. 220. And later on, I also show how I could get the... when you lag, I can't personally show it to you, but like, when you lag, it won't change where you are specifically because the movement adjusts to your frame rate. And then next up, now I'm checking for. Now we're going to go on to the keys. So when you press a key, the system will record it in an array, what key you've pressed, and also it disables sliding. So if I go to like my Google Drive and then scroll up and down using the arrow keys, you see how it's going up and down. Well, I can disable that, so it's just going to move the character up and down and not the whole web page. And it also tells me you release the keys as well. the system grabs your roll when you hit start, and then there's the movement system. So basically, the way the movement in the X direction works is practically pretty simple. It takes your current frame rate, divides it by 1,000, and then multiplies your character speed. So let's say you have 120%, that'd be that multiplied by base speed, which is the 30.72 blocks a second situation. But once again, that all gets reduced to the to 1,000. Your frame rate divided by 1,000. So it's a very small amount, but as you can see by looking at the actual character moving, you're moving quite a bit. Even though it's actually like 0.0 something a frame, over a second, it's 30.72. And that's it. Yeah, X and Y movement is not that simple. The only other change, if you're standing still and you get hit, that's dealt with automatically by dividing. It'll just take how much you got hit. Let's say the object pushes you 90 blocks to the right. Well, it'll divide that by your character's weight. And also, it'll divide it by your weight. So you just kind of like, if you get hit, you're not going to go. Or if you're like a stronger, weightier character, you're not going to go as far. But that's not really applied here because there's nothing that really shows. Oh, you got hit. Another thing to notice is the air resistance. If you're in the air and you try to move left and right, it's going to be a little harder than standing on ground. That's all it is. It's literally just you move 15% slower in the air. Yeah, that's it. The X direction actually is the simplest part of this whole equation. That took me the least amount of time to figure out. Great. Now, onto the Y coordinate system. So the way the Y coordinate system works is extremely, extremely, extremely difficult. So in order to make gravity, first off, we have to worry about this very, very, very beautiful thing called, you guessed it, gravity. Now, gravity in this game works at a negative 25. Let's see, right now it is. First off, I have to get whether you're even pressing jump, and you're on the ground. So once you achieve that, it sets the jump value. So let's say you have 4 jump. It multiplies it by this minus 90 value, which is 3 blocks. So you're moving 4 times 2. You're moving about 12 blocks. Now we have to apply that to the gravity. So gravity works pretty simple here. So value equals, and then the milliseconds times the frame time divided by 1,000 times your jump. So as I mentioned, your lift in this case, because that gets times 90. So let's say it's at 360 right now, and then you'll also just if you get hit, that also kind of gets applied here. But do not worry about that. Next up, but then you'll add gravity to the equation. So the gravity is 50 and 25. And you're going 270. It's only going to lower it down to 255. But whatever gets removed, so let's say 15 pixels, you go upwards. Guess what? Now the player.lift value gets decreased by 15 pixels. So you know how Parabola works? That's what I'm trying to recreate here. And then, of course, if you press down midair, you can remove all momentum, which is extremely helpful. And then, of course, below, when you scroll down, you'll see some more values that determine if you're jumping, not jumping, and then it sends that value back to the main function, in which its final steps is to draw. What the drawing thing does is everything you see on screen. The only thing to know outside of it drawing your current position is to at the bottom you see context.save and everything below that. So when the little rocket thing rotates, your little rocket launcher, what's actually happening is your whole screen is rotating, and then it resets the rotation back so everything looks normal except for the rocket launcher. Yeah, that's it for everything. That's the code. That's the coding side. That's JavaScript. All right, have a good night. Bye bye. Silly, silly. Good night. Hee hee ha.